Hello, today we are going to be working on solving applications that involve logarithms and exponentials. So we're going to look at a few of these, and we're going to be using a calculator quite a bit, so we're going to keep that on the screen throughout. So when looking through these, the most common application is using the Richter scale. And so the Richter scale measures earthquakes and been around since 1956. You can read that information as kind of the historical background behind it. But the most important part is this equation right here. And so m equals log e, and make sure that we know that that is a base 10. So it is not natural log. Capital E stands for something else, not the natural base. But log e minus 11.4 over 1.5. So e is measured in ergs. And m is the measure on the Richter scale. So E is measured in ergs, it's usually in scientific notation, and m is the Richter scale, we usually round that to the nearest tenth. And so since it's base 10, a 2 on the Richter scale is 10 times as bad as a 1. So you can kind of see that it's not like double, it's actually 10 times. So looking at using this, if we have an earthquake that releases 5.1 times 10 to the 16 ergs of energy, what did it measure on the Richter scale? Pretty straightforward, we can just plug in, and so we can say m equals log of E, which we're going to say is 5.1 times 10 to the 16 minus 11.4 all over 1.5. And so we can plug that in directly into the calculator. It's going to be important to use scientific notation. It's more efficient to use proper scientific notation, so we can type in a fraction. So we're going to hit alpha y equals, and then hit enter. And then from there we can type in a log, we're only using base 10. And then 5.1, if we want to enter in scientific notation, we can type 5.1, and then we only use this double capital E. So we're going to press second, and then the comma button, and that's going to give us E, which the E really kind of stands for times 10 to the exponent that we want to use, and so we're going to use 16. Close our argument, and then minus 11.4. And then in the denominator we have 1.5. We're going to hit enter. And so that's going to be a 3.53, so on. We normally write into the Richter scale to the tenths place as it says, so it would be a measure of 3.5. There is no like units or anything like that. It's just on the scale of that. So that'd be a 3.5 Richter scale earthquake. If we go the other direction, which is kind of where we're leading towards with solving these. How many ergs of energy are released? So we're trying to solve for E if we get a 4.7 on the Richter scale. So that means that using this formula, we're going to say 4.7 is equal to log of E minus 11.4 over 1.5. What's very important in this is that you do not round until the last step. If you round throughout the process, you're going to miss some key pieces, and so we want to make sure that we're not off by a few decimal places. So we're going to solve, we're trying to isolate this E. So we're going to isolate the log, and then we'll convert after that. So what we're going to do is multiply by 1.5 first. And so we're going to say on the calculator 4.7 times 1.5, and we don't want to round this value. We want to keep it exactly what it is. So that's going to be 7.05 is equal to log E minus 11.4. Then we want to add 11.4 to both sides. So we're going to add 11.4 to that. Which is 18.45, is equal to log E. And with that, what we're at right now is we can convert, or if you want to raise both sides to the 10th power, however you want to think about it, we are going to say that this is now, because this is a base 10, so this is really like 10 to the 18.45 is equal to E. However, we don't want to write that. That's not in true scientific notation. So we want to go back to the calculator. We want to say 10. We want to use the caret key. And then we want to say, sorry, the character, we don't need the second. So 10 to the 18.45. We hit enter, and that's going to be in scientific notation because you can see the E at the end. So we're going to go to 3 decimal places. So that's going to say 2.818. And then we don't use the capital E in scientific notation. We're going to say times 10. And then whatever's after that E, that 18 is our exponent. And that's going to be in ergs of energy. So if we want to work backwards, we're going to result in like a 10 raised to something in this case. And so we just need to make sure we type that into the calculator and then use proper notation. The calculator notation uses the E. We have to use times 10 to that. So very popular to use the Richter scale. So please be comfortable with that. And looking at a different example is that in chemistry, you can find the pH based off of this equation. P of T is equal to negative log T, where T is the hydronium ion concentration. So we want to find the pH of the solution with a hydronium ion concentration of 4.5 times 10 to the negative 5. We should recognize that that is going to be T. So all we have to do is plug in. So P of that, 4.5 times 10 to the negative 5, will just be negative log of that. So we can plug that into the calculator. And find out our information. So we don't need to use log base or anything like that. We can just say negative log of 4.5. Then we're going to use second E. It's not wrong to use times 10 to that. It's just more efficient. And then we're going to say negative 5. Close our argument and hit enter. And so we would get on a pH scale, we tend to use just 1 decimal place. It doesn't necessarily say, but we're going to just go to 1 decimal place. So that would be 4.3 would be the pH. Okay, we're not going to do any more with this, but you could work the other direction. So if we gave you the pH of something, you would use very similar to what we talked about in the last example of the Richter scale to solve for the hydronium ion concentration. So be able to work both ways with these, and using what we know about logs, you should be able to solve that. Looking at compound interest. Compound interest is whether we do compounding a certain amount, or if we do continuously, then you're just going to use either one of those formulas, making sure that we write R as a decimal. And so if we are doing this example, Cam wants to invest $3,000 at 3% compounded continuously, that should say that we're going to be in the PERT formula. So we're going to be using this one for this. And he's investing $3,000. That's the starting amount and the principal amount, so that's our P. We should know 3% is our R, but we're going to use 0.03. And then we want to figure out how many years to double that. So that means that our A is going to be double 3,000, which would be 6,000. So we can use this to say 6,000 equals 3,000 E to the 0.03 times T. And then we just solve for the E, and so we're going to divide by 3,000. So we get 2 is equal to E to the 0.03 times T. The only way we can get the T out of the exponent is if we are able to rewrite, or you can take the natural log of both sides, however you want to think about that. And so we're going to say that this is the natural log of 2 is equal to 0.03 times T. And then we don't have to write base E or anything like that. So we then divide by 0.03 on both sides. And that's what we're going to plug into the calculator. So our T would be ln of 2, all divided by 0.03. And so we can type that in. We can say that, get a fraction in our calculator, alpha y equals, and say natural log of 2 divided by 0.03. And so we would say 23 point, it does not say, so we would say 23.1 years, we'll say. And then if it says for exact years, we would need to round that up to say 24 years. Because of, on the 23rd year, we would not have that. So if it says round to the specific year, we always need to round up in those instances, depending on how the question is asked.